Hello, you're going to have to forgive me in this video because the numbers are not going to be pretty. Or not necessarily, I don't know. I'm just going to make this up on the fly. Just to give you an example in this video of how to solve a vector addition problem. One kind of problem that they might give us. So let's say that they tell us that you have a dog walks, let's say, 35 meters north and then 25 meters west. What's its final displacement? Okay, so let's draw the situation. You've got this, which is 35, right? 35 meters north, and then line tool. And then we said that it was 25 meters to the west. So if this is the starting point, this is what we want to find. We want to find the length right here. So we want to find this length, and then we want to find the angle. Because in this case, if we've got north, east, west, and south, hopefully you all know your directions. Well, this is going to be northwest, and we're going to find out how many degrees north the angle is of west, above west, north of west. Hopefully that part should make sense, whether it's north of east, north of west, south of west, or south of east. Hopefully you can figure that part out. It's just drawing it and figuring out where the arrow lies. That's the best way of figuring out whether it's north, south, what it is. Okay. So the first part that we're going to do is we're going to find the magnitude, right? How big this is. And because we know that the height is 35, and we know that this shadow kind of thing here, if you think of sine and cosine, you can think of them as if you shine a light straight down on the triangle, whatever the shadow is, that's the cosine, whatever the shadow is on the floor. And if you shine a light horizontally, whatever the shadow is on the wall, that's the sine. So shadow on the ceiling / floor, and then shadow on the wall. That's cosine, and sine. But in this problem, we actually don't need cosine or sine. And you'll see why in a second. Because basically all we really need to do is, well, use the Pythagorean theorem. So, right? Because square this, square that, add them together, and then take the square root. That part, hopefully you understand. It's just figuring out the length of this side of the triangle. So 25 squared plus 35 squared equals, let's see, 25 times, oops, let's view the scientific. 25 squared, you get 625, so 625 plus 35 squared, I think I remember, yeah, 1225. Isn't that neat how, like, you add 10, and when you square it, it's like almost double? I don't know, for some reason that impressed me. I don't know. Strange. Okay. When you add them together, so we got 1225 plus 625, we get 1850. So if we have 1850, the square root of that we get as 43.01. So I'm going to put 43.0. Gito. So that's the length of this vector, right? What's the angle? Well, let's think about it. What is the slope of this line? Well, the the slope is rise over run, right? Rise over run. or how much it goes up divided by how much it goes over. Well, the rise here, we've got 35, right? Because that's the how far he goes north. And then the run, careful, this is not 25. It's negative 25, right? Because he's going kind of, if this is 0, this would be positive, this area would be negative. So it's going to be over negative 25. And then you could simplify that. You could say that that's equal to, if you divide both the top and the bottom by 5, that's equal to negative 7 over 5, right? So that's the slope. What do we do with the slope? Well, we use that tan inverse function. So the inverse tangent of the slope, or the inverse tangent of negative 7 over 5, inverse tangent of the slope gives us the angle. So what is the angle? Well, let's find out. I gotta go to the scientific calculator in this case. So we do, what's the best way to do this? Negative 7 divided by, okay, 0 minus 5, because there's no way to do negatives on this. So we get 1.4. That's what we're taking the inverse tangent of. Remember, that's just the same as 7 over 5. And then I'm going to go inverse tangent. Will that work? I hope that worked. Yeah. That seems about right. Right? Does it? Yeah, that seems about right. Okay. So you put in the slope and you get out an angle. 54 point... No, this has got to be wrong. I'm almost positive. Crap. Okay, you're just gonna have to trust me. I'm gonna do it on a calculator, on my Windows 7 computer actually, because Windows 7 can handle it. So I'm gonna do, let's see, negative 7 over 5. So there we have our slope is negative 1.4. And then, actually that might be what I messed up. Yeah, that's what I messed up. Okay, let's open that again. Handy dandy calculator. So we've got 0 minus 1.4, we get negative 1.4, and then we're going to take the inverse tangent of that. And we get, no, okay, this calculator is just wrong. So I'm going to go on to this other calculator. You can do it with your graphing calculator. It's just the inverse tangent function. Oh, it is right. I feel stupid now. I feel really stupid. Okay, so it basically tells us that this angle right here is 54, and then it's 0.5 degrees. 0.5 degrees. I'm sorry, I probably confused you there, but you're taking that inverse tangent, and you basically put in the slope, and it gives you an angle. And the slope is the rise, or the height, divided by the run, or the distance. I'm going to do one more example problem, this time working the other way around. Maybe they'll ask you, they might give you, say, okay, a dog travels, say, I don't know, 10 meters at an angle of, I don't know, let's make it at an angle of 10, right? This is not drawn to scale. So what they want to know is, okay, how far did it go in the x direction, or let's say how far did it go north, and how far did it go east. This is that shadow thing again. The shadow on the floor is the cosine, or how far it goes in the x, and the shadow on the wall, this height right here, that's not it. This height right here is the sine, or the y value, the height of that point. The height of this point right here. So hopefully you remember this. One way that they always tell us is that with, like, say, sine is going to be equal to opposite over hypotenuse, right? And that cosine is equal to adjacent over hypotenuse. Well, one thing that we can do is, if we kind of take this and just multiply both sides of the equation by h in both of these cases, all we get is that h times the sine is equal to O. And O, the opposite, so in this case, opposite, O, that's this side right here, O, height, is H, so this we said was 10, right? We said was 10. So the height, or the Y value, maybe in northwards, you could say that's equal to 10 sine of 10, and you just plug that into a calculator. And then x, likewise, you can say that this is h times cosine equals a. You just multiply h times cosine over here, the h's cancel out. So you get the x travel is 10, because h is the hypotenuse, right, which is 10, cosine 10. Forgive the handwriting. Again, I'm getting a tablet soon. Can't wait. And likewise, you could have done this. You could have said, okay, this could be written as, let's name it Bob again. Bob equals 10, the magnitude, right? How big this vector is, how fast they're moving, how far they moved, how much force, whatever. That's what the magnitude is. And times, it's pretty much always, you can put the magnitude, or the size of the vector out here, and then just put cosine of whatever the angle is times I plus sine of whatever the angle is times j. And when you think about it, here, let me make it more obvious with all these parentheses. So cosine t, that's just the x part, and sine t, that's the y part, but each of those you have to multiply by 10. And that's what we got here, that the y part is 10 times the sine of t, which in this case was 10. And then the x part, here in the x units, remember I is x units, I'm sorry, j is y units. We get 10 times cosine of t, which t was 10. So 10 cosine of 10 is our final x portion. So if you were to add two vectors together, you just evaluate and add. Hopefully this helped. I know a lot of people just didn't quite understand, or at least they have some trouble with breaking down vectors into their components. Hopefully this helps. In my next video, this is the third time I've said this, in the next video I'm going to work on some two-dimensional projectile motion problems. I'll see you then.